will be very clear. This is M. This is N. Okay. Now this is L1 lens. This is L2 lens. And this refracted ray, first refracted ray, is acting as incident ray per second lens. Clear? Now, actually, we know that light ray has to pass straight line. Now, when this is a straight line, from the refracted ray and the actual incident ray which has been passed, then we say this one will be acting as delta 1. Let us say the change is delta 1. Clear? Now, from here to here, I draw a perpendicular line. Let this be height be h1. Let this be point be h1. Let I say this point is A. And from here to here, I say this point B, which is the height of h2. Okay, from A to L1, the height is h1. From B to L2, the height is h2. Clear? Now, what I'm doing here is actually from B to here, when the light has been here, it has to be refracted. Here is one point that I say this is the F2. So one consideration you must take, since the line trace are not parallel to the lens, it is the image, the refraction is not focusing on the F2, but this is not the actual focus point. Generally, we are assuming it as arbitrary focus, unknown focus. And this is the final image also we are saying it. Okay. Now what I do is I extend this lines. So since this is from the incident ray and the reflected there is change, I say this is delta 2. So since this is delta 2, this will also be delta 2. Okay. Since vertically opposite, since here this is the delta. This is the delta. Now we know that exterior angle is equal to sum of the interior angles. Sum of the interior angles. That is delta is here is the exterior. So delta is equal to delta 1 plus delta 2. So according to what is say the formula, that is S is equal to R theta, where S is the linear displacement, and R is the distance, and theta is the angular displacement. So we can write this formula, that is theta is equal to S by R. So here theta is equal to S by R. So in terms here, we can write delta is equal to, in place of linear displacement, that is what you're getting here is H, linear displacement, and R is the radius, how much you're taking the radius, that is from here to here, from where you're writing, this is H by F, H height by focal length. Now you can clearly write here, delta is what? H by F. H by F. Delta 1 is what? From the triangle you can clearly see, this is the one we are writing here. This is a triangle you're seeing. This is a triangle you're seeing. Here delta 1 represents H1 by F1. So here from here to here, from L1 to distance to up to N point, it will be noted as F1. And delta 2 and delta 2 is the height. So since you can see here clearly, it is somewhat, you can write it as E and somewhat as F, some point F. Okay. So since this, how much is the height? H1, and this is also will be the same H1 height. So this is one what you can write H1, delta 1 and H1 here. Now delta 2 is what? Vertically opposite. You can delta 2. Now delta 2 is what? This is delta 2. Since in the triangle you can see BL2 F2. This is a, you are seeing a small triangle. This one is H2 by F2. So this is the one. So delta is equal to delta 1 plus delta 2 H by F, H1 by F1 plus H2 by F2. Am I clear till here? Am I clear? Am I clear? Okay now. Okay now. Clear? Am I clear? Okay. Now, according to this, now what I am going to do here, right? I'm considering, consider A L1, A L1 and F2 dash. F2 dash. A L1 F2 dash. This is a triangle you're seeing, right? L1 F2 dash. This I'm saying this F2 dash. F2 dash. Where it is generally meeting F2 dash. This one is F2 dash. So I'm writing here F2 dash A L1 F2 dash A L1 F2 dash L1 F2 dash. Clear? Now, and what is the other triangle I'm seeing? B L2 F2 dash. This is another triangle I'm seeing. So they are similar triangles. They are similar triangles. These are both similar triangles. So according to similar triangles, we can take the ratio of the their sides. Now A1 AL1 AL1 by L1 AL1 to F1 A1 L1 F1 means L1 F1 up to here is the F1. This one is F1 from here to here. So I have already given, but again I'm clearly mentioning from here to here. L1 is equal to now B L2 BL2 up to L2 F2 up to L2 F2. Clear? BL2 F2. Clear? Now what is AL1? AL1 is what? H1. Now what is L1 F1? L1 up to F1 up to F2 prime. F2 prime. What is that? How much is the length? That is F1, H1 by F1. Now another one is what? H2, H2. Now what is L2 F2? L2 F2 is this one. This is the one I'm seeing. L2 F2 is this. For this distance, what I'm doing, I'm taking the whole distance, that is from L1 to F2, L1 to F2 minus what will I do? I separate this distance, that is L1 to L1 to L2. That is L1 to L2. Now from L1 to L2, if I remove the distance, I will get L2 to F2. From L1 F2, I remove L1 L2. I'll get F1 minus D. Right? What will I do? From F1, I remove the distance D. From F1, I remove the distance D. I'll get this. This is the length. Okay. Now H2 will be equal to H2 will be equal to H2 will be equal to uh, H1 into F1 minus D by F1, right? Now I'll number it. If it is, it will be easy. 1, 2, 3, 4, and this is the fifth equation. Now this is the sixth equation. Take sixth equation and put in second equation. What will I get here? H by F is equal to H1 by F1 plus H2. What I get? H1 into F1 minus T by F1 F2. Right? This is a seventh equation. Now in this seventh, I can remove the total height. That is what H1. This is also H1, right? I've written this is H1. Sorry, I have not mentioned H1 by F. Now H1 get cancelled. I get 1 by F is equal to 1 by F1 plus F1 minus T by F1 F2. Now if you separate and write it, what you get? 1 by F is equal to 1 by F1 minus F1 by F1 F2 minus T F1 F2. F1 cancel. Therefore 1 by F is equal to 1 by F1 plus 1 by F2 minus T F1 F2. Clear? Am I clear?